Hello students and welcome back to my channel Pratima's Rasayana, and this is Pratima ma'am. Today we are going to start another interesting topic of organic chemistry, that is classification of organic compounds based on the structure. But before that, if you like my videos, please subscribe to my channel and you can share it with your friends so that they also can learn chemistry. Let's begin. Organic compounds are classified into two main types. They are acyclic compounds, or also called as open chain compounds. Second is cyclic or closed chain compounds or closed compounds. So first two important types is acyclic or open compounds, open chain compounds. Second is cyclic or closed compounds. Now, how to remember this? It's simple. This is cyclic. That is, you will have a ring in the structure. And second type is you just have to add A in front of cyclic. So you will get the second type. Next, cyclic or closed compounds are further classified into two types. Alicyclic compounds. Alicyclic compounds. Second is aromatic compounds. How to remember this? So aromatic. So there will be a ring. In aromatic compounds, you have ring. And second is, the second type you can just remember, you have to add ALI or Ali before cyclic. So you will get alicyclic and aromatic. Don't get confused. The first one was acyclic, whereas this is alicyclic. Next, alicyclic compounds are further classified into two types. One is homocyclic, or also called carbocyclic. The second type is heterocyclic, non-aromatic. So again, alicyclic are classified into two types, homocyclic or carbocyclic. Second, heterocyclic, non-aromatic. So you have homo and hetero. Homo is same, hetero is different. So cyclic refers to rings. So homocyclic, here these compounds are made up of carbon itself. So the main important element is carbon in this type of organic compounds. Heterocyclic, non-aromatic compounds. So here you have a ring, but there is heteroatom, that is different atom is present along with carbon atom. Okay, it may be nitrogen, it may be oxygen, or it may be sulfur, etc. And they are non-aromatic. They are non-aromatic. Next category is aromatic. Aromatic compounds, you will be learning about aromatic compounds in detail in a separate chapter. Right now, aromatic compounds, they have benzene-like structures. Okay, so they are classified into three types. So the properties of aromatic compounds are different, which you'll be learning. But right now, aromatic compounds are classified into benzenoid, second non-benzenoid, third is heterocyclic aromatic. So again, aromatic compounds are classified into three types: benzenoid, non-benzenoid, and heterocyclic. First of all, benzenoid. So here you will have benzene kind of ring in the compound. Second is non-benzenoid type of compounds. The name itself tells you that this will not have a benzene-like structure in its. Third is heterocyclic aromatic compounds. Again, here along with carbon, there will be some heteroatom like nitrogen, sulfur, etc. So it is called as heterocyclic. You will have a cyclic ring, aromatic ring. So this is the classification of organic compounds. Now, if you want example for each of this, let me give you. Okay, I'm going to wipe all this and individually I will give you examples. Let me give you example for acyclic or open chain compounds and cyclic or closed chain compounds. Let's begin. Now you take example of ethane, that is CH3, CH3. So this is an example of straight chain compound. So your carbon is linked to another carbon directly, that is in the form of a straight chain. So these compounds are called as straight chain compounds. Second category, you have branched compounds. For example, this one. So this is a chain, okay, and then there is this CH3 group which is attached. So there is a branching here attached to this carbon, okay. So this is called branched chain compound. So example of this is isobutane. So this is isobutane and this is ethane. Same way, there is one more example, that is CH3 C double bond OH, which is called as acetaldehyde. Okay, so these three examples, if you see here, you will not find any ring, so it comes under acyclic or open chain compounds. Now let's move on to cyclic or closed chain compound. So here, first you just keep in mind there's a cyclic ring. So let's take an example. The first example is cyclohexane. So it's a 6-sided figure and there's a ring, so we call it as cyclo, which refers to ring, cyclohexane. And this is 3 carbon compound and it's a ring, so we call it as cyclopropane. If there are 3 carbons, you call it as propane. So since there's a ring, we call it as cyclopropane. Okay. So these were examples of acyclic and cyclic compounds. Now further, I'll be giving you examples of alicyclic and aromatic compounds. Let me wipe this and focus on this part. Cyclic, as you know, they're classified into alicyclic and aromatic compounds. So alicyclic compounds are the compounds where there is a cyclic ring and the carbon atoms are joined together to form a cyclic ring. Okay. So alicyclic compounds are further categorized into homocyclic or carbocyclic. Now, as the name tells you, homo means same type of atoms. So in the ring, there will be same type of atoms, that is carbon atoms. It's also called as carbocyclic. So here the ring will have only the carbon atoms. For example, cyclohexane. So it is a 6 carbon ring. So here altogether 6 carbon atoms are there at this place, this position, here, and here. So it's called as cyclohexane. Then it might be this one. So this is also a 6 carbon compound, but I will give a double bond here, and this is called as cyclohexene. This is hexane, A-N-E, because here you will have all carbon-carbon single bonds, and this is called as cyclohexene, E-N-E, because here you have one carbon-carbon double bond. So this is called as cyclohexene. Now next category is, the next type is homocyclic and heterocyclic, but non-aromatic. That is, in this there will be ring, but along with carbon atoms there will be one heteroatom, that is a different atom. For example, let's take this example. This is called as tetrahydrofuran. Tetrahydrofuran, F-U-R-A-N. So here you will see, here there are carbon atoms and this is one heteroatom, that is oxygen is present. So it is called as tetrahydrofuran and it is an example of heterocyclic non-aromatic. Now let's move on to aromatic compounds. First you will have benzenoid. Benzenoid type of compounds contain benzene ring. For example, let's take benzene. This is an example of benzenoid type of compounds. You also have 2 benzene rings which are attached to each other. So this is called as naphthalene. So both are aromatic compounds. Next you have non-benzenoid. Okay, non-benzenoid type of aromatic compounds. So you can take an example of tropolone. So here, how many you can see that this structure and this structure, there is difference. So this is benzene-like structure, whereas here, if you see this example, it doesn't look like benzene, or it doesn't look like benzene-like structure. So it comes under non-benzenoid type of compound. So here altogether, how many carbon atoms are there? This is 1, 2, 3, 4, 5, 6, and this is 7. So you have to draw 1, 2, 3, 4, 5, 6, 7. A 7-membered ring, and then you have to attach a double bond O to it. So this is called as tropolone. It's called as tropolone. And the last category is, which I'm going to write it here. Heteroaromatic type of compound. Heteroaromatic type of compound. Heteroatom is present. There is a different atom present other than carbon. For example, let's take this is called as furan. It's called as furan. So this is an example of aromatic compound, and it is heteroaromatic because there is heteroatom. That is, other than carbon, there is one different atom present. So in this furan, there are totally 4 carbon atoms at this place, 2nd, 3rd, and 4th. So now if you see this and this structure, both are a 5-membered ring to which oxygen is attached, but only difference is here there are no double bonds, all are single bonds, whereas here you will have 2 double bonds. So that's the only difference. Now I'm going to draw a structure on the board, and you have to tell me what is the name of that compound. Okay? But I hope you have understood this concept, the classification of organic compounds. So please tell me in the comment section what are the names of these 3 compounds. Let me label it as A, this is B, and this is C. So I would like to know your answer. So I hope you understood today's concept. I tried to give examples also so that it is easier for you to understand. So in my upcoming videos, I'm going to bring some more concepts and some topics related to nomenclature of organic compounds, and then we will move on to isomerism in organic compounds. So for now, I'm going to stop this video, and I hope you subscribe to my channel, and if you liked the video, please press the button and share with your friends. If you are struggling with chemistry, I hope it helps you, and I hope it helps your friends also. Thank you for watching.